We've been learning to use the periodic table to tell all sorts of information about our atoms. Now, typically, an atom has the same number of protons and electrons. When that's the case, we say it's neutral. But sometimes an atom loses or gains an electron and becomes charged. When that happens, we call it an ion. And it turns out that the periodic table will help us figure out just what charge different atoms will form. Let's figure out how we can do that with the periodic table. So basically here what we're thinking about is elements that have an unequal number of protons and electrons. So if you take a look at the atom below, you'll see that it has one proton, but two electrons. And that means that its overall charge is -1. And it turns out that just using the periodic table, you can actually predict what charge different elements will tend to take on. So the key factor that we're going to use is the fact that the position of an element on the periodic table allows us to actually predict what charge an ion will take on. How does that work? Well, it turns out that elements tend to want to have the same number of electrons as a noble gas. What's a noble gas? Well, a noble gas is just those elements you see in that far right column of the periodic table. And those are really stable. So examples would be like helium, neon, argon. And because they're so stable, and their stability is due in part to the number of electrons they have around the atoms, other elements tend to gain or lose electrons until they have the same number as a noble gas. So that's the fact we're going to use to think about what charges different ions will have. So let's take a closer look at a small section of the periodic table. So here we once again have the noble gases marked. And let's think about what's going to happen if the elements that we see here gain electrons to look like a noble gas. So if we zoom in here on fluorine, fluorine has 9 protons and 9 electrons in the neutral atom. So if you just find fluorine and it's neutral, it'll have 9 protons and 9 electrons. Now, the key question to ask yourself is how many electrons does fluorine need to gain to look like the noble gas neon? And so if we go over and we look at neon, we see that it has 10 protons and in a neutral neon, 10 electrons. So if we go from fluorine to neon, we're going to add an electron. So we're going to add an electron if we go from fluorine to neon. And remember, when you add an electron, something becomes negatively charged. So that means that fluorine tends to be charged with a -1. And that's actually true for that whole row. So fluorine and chlorine below it, and bromine, which is below it, which you can't see on this periodic table, also tend to form ions that are charged -1. So I'm going to erase that writing there, and now let's think about what happens to oxygen. Well, oxygen has 8 protons, and hence when it's neutral, 8 electrons. And if it wants to go to neon, well, then it's going to have to gain 2 electrons to go from 8 to 10. So that means that oxygen is going to tend to gain 2 electrons. And when oxygen gains 2 electrons, it becomes charged with a -2. So that means that what we have here is that the first column with fluorine and chlorine tends to become charged -1 because they need to gain 1 electron to look like a noble gas. On the other hand, the elements in the group with oxygen tend to be charged with a -2. And this just goes on for nitrogen also. So if we take a look at nitrogen, nitrogen has 7 electrons and 7 protons. And for it to look like the noble gas neon, we have to go all the way across and get 10 total electrons. That means it's going to add 3 electrons and become charged with a -3. Now, it's important to note the same thing happens for phosphorus, sulfur, and chlorine, those elements below nitrogen, oxygen, and fluorine. And let's just take a quick look at that. So we'll erase this writing here. If we think about phosphorus, phosphorus isn't going to look like neon. It's going to instead look like argon. So here's phosphorus. It has 15 electrons. And it's going to go across 1, 2, 3 elements to get to argon, which has 18 electrons. So it's also going to gain 3 electrons. So that means nitrogen and phosphorus would tend to become -3 charged so that they could look like those noble gases. So these are negatively charged ions. And negatively charged ions we call anions. And that's what tends to happen on this side of the periodic table. When we go to the other side of the periodic table, the behavior starts to change. So now we see a fuller picture of the periodic table. And let's take a look at what would happen to lithium. So lithium over here, in its neutral form, has 3 electrons and 3 protons. And it really has 2 options, right? It can gain 7 electrons and go all the way over here to neon. And that would be plus 7 electrons. And that would give it a negative 7 charge. That doesn't happen. Why not? Because positive 7, or adding 7 electrons giving a charge of negative 7 is super unstable. Instead, what happens is lithium actually loses 1 electron to go to helium. So lithium looks like helium in terms of the number of electrons. So it goes from having 3 electrons to having 2 electrons. So here we're going to lose an electron. And when we lose an electron, that's going to make our lithium charged with a positive 1 because we got rid of negative charge. So when you get rid of that electron, you get rid of the negative charge, and that means lithium would be overall positively charged and positive 1. So that first column there with hydrogen, lithium, sodium, and potassium right there, that whole thing tends to become plus 1. So that whole first column there will tend to lose an electron to look like a noble gas on the other side of the periodic table and become positively charged. So if you take a look at sodium, which has 11 electrons, it will tend to lose 1 electron, and that makes it look like neon over here because neon has 10 electrons. And so sodium, just like lithium and hydrogen, will tend to become positive 1. All right. Now let's take a look at what happens in the next column over. Beryllium, right here, has 4 electrons and 4 protons normally, and it also will lose 2 electrons and go over here to look like helium. So when it loses 2 electrons, that makes it positive 2. So I get rid of 1 negative charge, that makes it positive 1. I get rid of another negative charge, that makes it positive 2. So everything in that group tends to be plus 2. And everything right here tends to be plus 1. So the group or the column that our element is in will tell us what charge we actually will have on our different elements. And that first column is plus 1, the next column is plus 2. And here on the next page, we're going to show you what all the charges are based on column. And so we see that on the far left here, that hydrogen, lithium, sodium, potassium tend to be positively 1 charged, the next row positively 2. And then way over here, we get negative 3 for the nitrogen column, negative 2 for the oxygen column, and negative 1 for the fluorine column. One last thing to add is aluminum, kind of a special case. It has 13 protons and electrons in the neutral element. And what it tends to do is lose 3 electrons so that it can look like neon. So it's a good idea just to remember that aluminum is positive 3. Now, just like those negatively charged ions over here are called anions, the positive ones have a name too. So anions are negative, and positive charges are called cations. So it's a good idea to remember that positive ions are cations and negative ions are anions. And so now we have everything we need to predict the charge that an element will take on when it becomes an ion based on the position on the periodic table. So we're going to go through a few practice problems now to take a look at what this looks like. So one note before we get to the practice problems is that I've talked about the columns with hydrogen, beryllium, with nitrogen, oxygen, and fluorine. One thing to keep in mind is that D block, that big block in the center of the periodic table, doesn't actually have good rules for predicting the charge. And so there, we know that they're positive. Those always turn out to form positive ions, but you don't know how positive. So we can only really predict charges for these guys on the far left and the far right. So now let's go ahead and practice. So here we have 6 different elements, and we want to know what charge will they tend to take on. And all we really need to do here is find it on the periodic table and see what column it's in. So for phosphorus here, P, let's go find phosphorus. Where is phosphorus? Well, phosphorus turns out to be way over here in this column, which has a charge of negative 3. So phosphorus tends to have a charge of negative 3. So predicting that charge, we just say, okay, this is going to tend to be negative 3. That means it's going to tend to gain 3 electrons. Okay, the next guy we have is potassium, and all we have to do is go locate potassium. Potassium's in our first group right here. below hydrogen, lithium, and sodium. And those ions, those elements tend to form a positive 1 ion. So potassium becomes a +1 ion. All right, now let's look at As. As is all the way over here below phosphorus, and arsenic tends to form an ion that's -3 charged, just like phosphorus above it. And so here we say, okay, this tends to become -3. So you can see this process is relatively straightforward. You're just comparing the position of the element to the column it's in, and from that column figuring out what its charge is. So now we go to chromium. This turns out to kind of be a trick question. Why is it a trick question? Well, chromium is way down here in the middle of the periodic table. That's part of the D block. And there's just no good rules for the D block. So we know chromium's positive. Everything in the D block turns out to form positive ions, but we don't know how positive. So we'll just say positive, and we don't know how positive. All right. Next element we have is N, or nitrogen. And nitrogen we see over here also in that same group with arsenic and phosphorus. And so it also forms ions with a -3 charge. So the key thing here is just remembering which columns have which charges. So you have to kind of memorize that the first column's +1, the second column's +2, and so forth. All right, last element on our list, calcium. Where's calcium? Well, we can go find calcium. It turns out to be right here. And things in that column tend to form a +2 ion. So that's it. That's how we can use the position of an element on the periodic table to determine what its charge would be if it becomes an ion. So lots of times you have neutral atoms around. They just have the same number of electrons and protons. But if any of these guys that we've talked about become an ion, that is, they give up or gain electrons, we can now predict how many electrons they would give up or gain. That does it for this episode of Real Chemistry. Thanks for watching. Please check out my videos on my channel. Please subscribe to get updates about new videos. And as always, if you have any questions or comments, please leave them below. Hey.